Section 4.2, Natural Exponential Function, Part 1. Okay, the natural exponential function is of this form. F of x is equal to e to the x power. Notice we, like all exponential functions, have the variable in the exponent. Our base e, the base e is a constant. Base e as a constant, let's look at what e represents. E is a special number. We know pi to be 3.14. E is also a special number called the Euler's number. E is 2.718. So here we have an exponential base e, base 2.7, raised to the x power. When we look at the graph of our natural exponential function, it's going to be and have properties just like the sections before. Domain, all real numbers. Range, 0 to infinity, unless there is some sort of transformation. Horizontal asymptote at the x-axis, and increasing, there's an error in the book here, as long as our base is greater than 1. Our graph is increasing. Our base 2.7 is greater than 1, so we have an increasing graph. Decreasing was the fraction. Okay, so in red, here's what the graph of e to the x is. Base 3, base 2, base e is base 2.718, and we're looking at the red graph. Okay, if we jotted down a couple of points, our usual for plugging in x values, or my usual, -1, 0, and 1. If I took e to the -1, I'd put that into my calculator and get out a decimal. E to the 0 is 1. E to the first is 2.718. I can plot 0, 1. I can plot 1, 2.718. And that just kind of gives us a little bit more detail in the e to the x graph. But everything that we learned before applies, only we're looking at base e, base 2.7. Okay, graph the function not by plotting points, but starting from the graph of e to the x. Okay, so how familiar should that be for directions based on what we've been learning so far? Same directions. We're going to graph the function not by plotting points, but by looking at the transformation of e to the x. Then we'll state domain, range, and asymptote. Okay, let's first look at transformations. From last time, if the negative is out front of the function, then that was a flip on the x-axis. But that's not what we have here. Here we have replaced x by a negative x on the inside of the function. Since we're on the inside of the function, where do you think that we're going to flip our graph? We're going to flip on the y-axis. Okay, here we're subtracting 3, so that's going to move us down 3 units. Okay, so if we were to first flip on the y-axis, we would fold our piece of paper right here at the y-axis, folding that piece of paper, and that dot was marked in wet ink. We would be here at -1, 2.718. If we flipped on the y-axis, that wouldn't do anything here. We would see, if we flipped on the y-axis, a graph that looks like this, e to the -x. Okay, next we're going to move our graph down 3 units. What I'm going to do is I'm going to start with the horizontal asymptote, instead of at y equals 0, we're going to be at y equals -3. There's our new horizontal asymptote. Okay, everything gets moved down 3 units. Okay, so we're going to go 1, 2, 3. There's our new y-intercept. We're going to go down 3. 1, 2, 3. There's our new y-intercept. Okay, so let's slide that graph down. Shape doesn't change. We're going to slide our graph down, and this gives us e to the -x minus 3. And there's our graph. Okay, as for domain, automatic, what's the domain? Negative to positive infinity. As for range, transformations were involved, so we got to pay attention to our range. Y doesn't ever equal or cross this -3 asymptote, but does get larger from there. Okay, so our range would be -3 to positive infinity, and then our asymptote is y equals -3. And there we go, just like the section before, only we're working in base 2.718. Okay, so here, let's just talk about the transformation. We're going to, flip where? On the x-axis. And we're going to move our graph how? Up 1. Okay, so we're going to flip on the x-axis, and then we're going to move our graph up 1. So that means y equals 1 is our new asymptote. So if I move this up 1, we would be here, and our graph would look like this. Okay, here's a WebAssign graph. Graph the function not by plotting points. So you can see that our homework questions are very similar in WebAssign. Here we're looking at section 4.2. This is problem 10 in the algebra part of the textbook. Okay, what's our transformation? We're not starting by plotting points. We're starting by looking at this graph e to the x and seeing how it transforms. We're going to flip on the x-axis, and then we're going to move up 5 units. Okay, graph the function not by plotting points, but starting from our basic graph e to the x. Our basic graph e to the x is here. Okay, so what are we going to do? What's our transformation? We replaced x on the inside of the function. On the inside of the function, we replaced x with x plus 1. Inside moves do opposite of what we think. So we're going to move left 1 unit. We're subtracting, so then we're going to move our graph down 2. Okay, so let's go ahead and do this one. Okay, so we've got 0, 1, and we have 1, 2.718. And here's our e to the x graph. We are going to move left and then down 2. Okay, so left and then down 2. Here's our graph. We're going to move left 1 and then down 2. Left 1, down 2, and there's our new graph. Okay, I'm going to work with our horizontal asymptote. Now, if we slide this left, that really doesn't have any effect, but if we move it down 2, we would be here instead. Okay, so we're going to take this focal point, we're going to move it left and down 2. What that would result in is our e to the x graph shifted left and down 2. Okay, so left 1, down 2. And there we go. E to the x plus 1 minus 2. Okay, one last example. Nope. Let me get rid of that. Here's how our graph would look in WebAssign. This is WebAssign 4, section 4.2, problem 15. Now, in WebAssign, you'll have multiple choice questions that you would select from the work that you've done. Okay, what's the domain? All real numbers. What is the range? The y values. The y values start but don't equal -2, go up to infinity, and the asymptote y equals -2.